Start operations. Excellent. Welcome to the exida seminar on SIF verification, scaling the 3 barriers. And you might ask, what 3 barriers? Yeah, believe it or not, I like to explain things this way because there really are 3 separate things that you must check to make certain that any given safety instrumented function design meets a given SIL level. And we're going to talk about these 3 barriers today. I will also note that, get the screen, there we go. I will also note that exida does have a more detailed web seminar on each of these topics, and we will be presenting them again in a few weeks, so stay tuned to the exida web seminar series if you'd like more information on these subjects. Of course, all of this is free. My name is Bill Goble. I have 40 years of experience, and most of that, now a majority of that, has been spent in the world of functional safety. I spend a lot of my time studying reliability engineering and failure rate data, 2 essential topics that are part of these barriers. And so I think I understand this pretty well, and I hope I can do a good job explaining for you. I just want to mention again, it was on this previous slide, that there is a Q&A tab at the top of your screen. Never hesitate to type in a question. I see someone just did. Okay. It's not in English. I'm sorry, I can't answer questions that aren't in English. Maybe we should get a group of interpreters here, but right now, please type any questions you have in English, and I'll be happy to give you a verbal answer. Type a question at any time. If you have a comment, if you say, "No, hold it, that's not what I thought, you're saying something different than I was taught," then type up a comment and I will address it. We're here to help you. These web seminars have a tiny bit of a commercial in them, yes, but they are here to promote functional safety. That's my job. I work for a company called exida. We've spent a lot of time in many different industries. A lot of our work is in automation, process industries, automotive, and semiconductor. exida does a lot of different things. We actually help people, end users at the systems level. We have a special group that does product certification, and we believe our records indicate we've done more process industry certifications than any other company in the world. We do training, some of it for on-site, and we charge for some of it free, like this. We have engineering tools, reference manuals, and exida operates the CFSE Professional Certification Program. We're proud that we have developed many of the analysis techniques used in industry today. And when we do such a thing, we write them up. We describe exactly what we're doing. We don't hide anything, no secrets. Our databases are all public. We provide all the information readily available. Now, we do charge for some of this, but we've got to pay for lots of engineers who keep doing the research to advance the sciences. We must all remember that our functional safety standards, IEC61511 and IEC61508, are based, in my view, on 2 fundamental concepts: a safety life cycle, a detailed engineering process designed to help us reduce or eliminate systematic faults, in other words, design mistakes. That's why many of the requirements in these standards are process requirements, things you must do to analyze, review, and test your designs. The other fundamental concept is a probabilistic performance-based system design to deal with random failures. And that's what we're talking about today. How do you verify that any given safety instrumented function design meets a target SIL level? Now, that's one of the fundamental concepts in this standard. And although it can be argued that there are different ways to do things, many members of the committee argued for years that a prescriptive, rule-based approach would be better. The problem with that is it does not allow for new technology. It does not allow for inventiveness. It does not allow for creativity. It does not allow engineering to advance. So I'm very pleased that those on the committee, and I was on the committee, on the U.S. committee of SP 84 for a long time, and I attended some of the 61508 committee meetings directly. I'm pleased that most of the members of the committee chose to go with this probabilistic-based concept. Now, what it means is, let me just check status screen. All right, most people are in good shape. Let's just keep going, of course. I have a design. I have a set of instruments and transmitters, a logic solver of some type, likely a safety PLC, and some final elements. And I want to know, does this design meet SIL 2 or SIL 3? We do safety instrumented function verification. Now, at this point, we have selected the equipment we're going to use. We have a design with a given architecture. We have a proposed manual proof test plan in place. And we are going to do some checking and some calculations to verify if our design is acceptable or not. There are 3 barriers that we must check. Barrier number 1, what is the systematic capability of the instruments we have chosen? Are they capable of being used in the SIL level that we need? Barrier number 2, we calculate the probability of failing dangerously, the probability of failing dangerously, either an average for low demand or a probability of failure per hour for high demand, continuous demand systems. And barrier number 3, we check architecture constraints. And we did a whole seminar on that last month, and we'll do it again in a few more weeks. There are limitations on architecture. Now, some of the limitations make sense, and some of them, in my opinion, do not make sense. And therefore, the new version of the standard 61508 has a new criteria called Route 2H, which ironically completely matches the prior use criteria in 61511. So I don't see how the 2H could be controversial at all. It matches something we've had for many years. 3 barriers. We have to check 3 different things. And we achieve compliance only when all 3 indicate we've met a particular SIL level. Did you know that? I heard a lot of people spend a lot of time just calculating probability of failing dangerously. Probability of failure on demand, you might call it. And think when they finish that, job is done, move on. Obviously, I meet criteria. Well, maybe you don't. And maybe your methods need to be checked. But you also must check SIL capability and architecture constraints. Now let's talk about each barrier in a little more detail. Barrier number 1, the SIL capability. Basically, we are following 61511. And 61511 says you must justify the equipment you choose. And you must do that by either choosing proven in use hardware devices or using hardware developed and assessed according to 61508. So you do have some choices in how you justify the equipment SIL capability. And we'll talk about that in a little more detail. Now, I'd like to remind everyone that what we're talking about here is safety integrity. That equipment must be selected to match your application, and that comes first. Never select an inferior piece of equipment for your application just because it has a SIL certification. I know that's even not in our company's best interest to say such a thing, but that's exactly what must be done. We must pick equipment that's totally suitable for any given application. Then we must justify safety integrity requirements, and we must document the justification. What am I talking about when I say application requirements? Obviously, you need to pick an instrument that will perform all your needed functions. You must pick an instrument that's rated for your expected environment. You must pick instruments that are where the materials are compatible with your process conditions. I have seen some nasty problems in the process industries when materials in field instruments did not match the process. Pressure transmitters, for example, in hydrogen service have to have special diaphragms because you get hydrogen embrittlement in many different metals. And then, of course, if a product has a safety manual, you should check the safety manual to see if there are any restrictions which would prevent that product from operating in your particular environment. Given that you've done a good job on your application match, and of course that's what we've been doing for years. We've been picking instruments that match the appropriate requirements of our application. And I really do mean that comes first. Given an application match, then you have to justify the safety integrity of a product. And as I've shown you from a chart in 61511, there's two choices, 61508 certification or prior use justification. And we did an entire seminar on this subject, and it is recorded and available for you. So we're going to cover it in a little more summary way today. Two choices, 61508 and prior use. Well, obviously the easiest task if I were choosing equipment, I would most certainly pick 61508 certified products. Obviously, that statement is somewhat self-serving since exida is the largest product certification company in the world today. I just got a comment here. Yeah, the question was, will we have access to the recorded webinar? And the answer is yes. Clear that out so my status screen looks good. All right. Please do not hesitate to make comments, ask questions at any time. I'm going to check the other status screen. Still a few people that don't have audio. Oh, well. Everything's okay from my end. Why 61508 product certification? In the product assessment process, a lot of detail is covered. The design quality, the hardware design itself, the software design itself. And there are many, many requirements in IEC61508 that a manufacturer must meet. I'd like to say the certification should be done by a technically competent and well-known third party. And that statement is there for one simple reason. When I verify, I'm asked to audit a systems level design, and a product has been self-certified by the manufacturer, I would accept that, but I want to see the assessment report, not just a single piece of paper signed by the quality manager of a manufacturer. And there's a reason I want to see the data. I want to see the backup. Exida was once asked to audit an instrument manufacturer. They failed the audit very badly. And 3 months later, they decided not to get a third-party certification. 3 months later, I saw a self-declared 61508 certification. It made me lose all faith in manufacturers' self-certifications. Okay, a comment. Recently, I had to reference FMEDA manuals, and neither of them have any reference to systematic capability. Why is this? FMEDA is an analysis of the hardware. It is a partial. It's a piece of the work that needs to be done for 61508 certification. Systematic capability is done in a different report. Systematic capability assessment is not part of an FMEDA. And to be very clear, an FMEDA alone is not the same as a 61508 certified product. I appreciate that question. Thank you. Who determines the competency of the third party? Good question. For the most part, certification bodies are accredited by accreditation bodies. There is typically one government-sponsored accreditation body in each country, although some countries don't have it. Many countries have an accreditation body. The accreditation body is typically part of the international IFC or something, International Federation of maybe IFA. Anyway, in the United States, the accreditation body for functional safety is ANSI. ANSI is the signatory for the United States for IEC61508. Exida is accredited by ANSI to do functional safety certification work. So in effect, the answer is, who determines the competency of the third party? Well, formally, it is ANSI in the United States, but in fact, it's the market. You need to judge the competency of the people. And I would do it by looking at what have they done? Who attends the committee meetings? Who has written the books on functional safety? Thanks for asking. Will you please shed some light on systematic? Yes, that's coming. It's coming very soon. We have a 3144P SIS. The temperature reading is affected by thermal temperature. Around 40. Is this an issue for SIF? Is affected by thermal temperature. I assume you mean environmental, the outside environment. And I don't remember the actual ratings, but the bottom line is products are certified per a given environment, and if you're within that environment, they should be working just fine. If you have a product that is not performing properly within the certified environments, you really need to tell the manufacturer, and the manufacturer will, if it's a potentially dangerous problem, the manufacturer will tell the a competent certification body reviews the manufacturer's field failure return data at every surveillance audit. And Exida, for example, does a surveillance audit every 1 to 3 years. If you have a 3144P with a problem, go tell the manufacturer. Questions like this. NRTL in USA. Is ANSI an NRTL? NRTL is Nationally Recognized Test Laboratory. That's a program for electrical safety. NRTL has nothing to do with functional safety. ANSI is an accreditation body. Those who become NRTLs are test laboratories. Exida does not do electrical safety work. That's primarily FMCSA. I think FMCSA, possibly UL. Thanks for asking. Good certification assessment has an assessment report. The assessment report and the certificate, at least with Exida, will give you the SIL capability rating. It's very good to make sure that you check the assessment report. And in Exida, we require all certifications done per the new standard 2010 to publish the assessment report on the website. Is product more questions? Thank you so much. Is product certification acceptable, or is it required for all SIF instruments? I'm not certain what you mean, but any SIF designer must justify the SIL capability of every piece of equipment in the SIF. Typically, that's done on a per instrument basis, and it's either done via the certification, as we were talking about, or what we're about to talk about, prior use justification. ISA technical reports say that certification means recognized by an NRTL. Yes, I did see that. I did see that, but it's a technical report, and it's simply not correct. Sorry. Well, somebody there just doesn't understand. Not everyone understands things the way certification bodies do. Besides, I thought I went and changed that. Is there any way to verify systematic capability besides certifications? Yes, you can do your own prior use justification. Absolutely no problem. I did want to mention before we get into prior use justification that you must check the certifications to make sure they're applicable for your particular application. I have seen many certifications that are basically derived for machine safety. And machine safety typically means using products in a very dynamic moving application. And so for field devices, especially field devices with mechanical components, you want to be extremely careful. You can usually see if there's a problem by looking at the assumed demands per year. If you have a process that doesn't have a demand at least 10 times per year, then this particular certification would not be applicable. If you want to see and find products with certification, the safety automation equipment list on Exida is, I consider, the best source in the world. This list has products from Exida certification as well as several other certification agencies. Exida will list products either done by Exida certification or any other credible certification agency when we're given permission by the manufacturer. Maybe after the web seminar, go take a look, but you can type www.saelonline.com. Didn't have to type that, did I? Now, the question earlier was, is there any other way other than certification? And the answer is yes. You do not have to buy certified equipment. You can do your own justification. Now, first, I recommend you call the manufacturer and ask if the product you're looking for is about to be certified, because I know for a fact that there's a lot of certifications going on right now. Another question came in. Vendors provide prior use certification. Vendors provide prior use certification. I think what you mean is that in the world of 61508 certification, there are 3 different ways that a manufacturer can get existing products certified. In 61508 Part 3, they're called Route 1S, Route 2S, and Route 3S. And manufacturers can take credit for, manufacturers can take credit for their field experience if they have a good field failure feedback system. And exida will use any of the routes in 61508 to provide certification. But there's nothing, it's not the same as what we're talking about now. It says, I have seen one by Rosemount certified by exida. If you have a product certified by exida, you do not have to do any prior use justification. The certification agency has done the work for you. If, however, you call the manufacturer and they're not getting certification, you may absolutely take responsibility yourself, set up your own self-certification process. It's absolutely allowed. Now, when you look at 11.5.3 of 61511, it gives you the 4 major criteria that you must judge when doing your own prior use justification. You have to effectively audit and understand and judge the manufacturer's quality management and configuration management systems. I was attending a ISA SP84 meeting last week, over internet meeting, and this topic came up, and one of the participants said how important it was to judge the configuration management system because they were having huge problems knowing the versions of the instruments. And every time the manufacturer changed the design, their experience may or may not be applicable. So it's very important that you understand exactly how the manufacturer notes version design changes. Next step, you have to make sure the manufacturer adequately identifies and specifies the product. Now that relates to version control also. You have to make certain that when the manufacturer changes the design, that design change is identified on a product. Now typically the best way is you can look at a product and either the hardware version or the software version is embedded in the model number, or it's available either on the outside label or via a handheld device or HART type devices. Number 3, you have to have a demonstration of the performance in similar operating profiles and physical environments. In other words, you really have to use this stuff and make certain that it really works well. And, of course, document that. And you have to have a sufficient volume of operating experience. Now, that's a pretty good justification scheme in my mind. If I thoroughly understand the manufacturer's quality systems, how they design products, and I audit them, and I document that, and I use a product, and I thoroughly understand when they make design changes, so I know that my experience is still valid, and I document a good volume of operating experience, you have a pretty good idea that a product works or does not. 61511 does not, however, give you specifics, so everybody can judge how much volume of operating experience you need on their own. But at exida we have recommendations, and when people ask us to help them do prior use justification, which we do, we will audit a manufacturer's quality system. For SIL 1, we will verify ISO 9000 quality systems. We will verify a documented design process. We will verify that they have done an FMEDA, or we will get the FMEDA report. And by the way, an FMEDA report is valuable evidence to be used in a prior use justification. But FMEDA alone is not the same as certification. If you have an FMEDA report, you still have to do your own prior use justification, and you must take responsibility for the selection of the equipment. For SIL 2, we do all of the SIL 1 plus a detailed review of the design, test, and documentation process. We review the warranty return data and the field failure feedback system. For SIL 3, we would do all of the SIL 2 stuff, plus we would do a full audit of the design and manufacturing process per IEC61508 SIL 3. In effect, we would do most of the work required for a certification. Another question, is the certification done by exida based on mathematical exercise, or does it include verification of the performance of the device in the field? Good question, thank you. Exida does both. It's essential that the design attributes of any particular product be evaluated. The FMEDA techniques that we use to evaluate the hardware are absolutely a mathematical exercise based on years of field failure research and 60 billion unit operating hours of field failure data. But for every project, we also verify field failure performance from both the manufacturer's warranty return data and from our end user data collection system, and our end user program called SIL Stat. So we do both. I think it's important to do both. Another question, prior use justification based on your presentation would appear to be quite complicated. Well, this is serious business. Safety. Given the complex nature, perhaps involving several sub-suppliers, if we procure catalog instruments, would this not be sufficient? Well, no. Well, if you wish to comply with 61511, you can't just procure a catalog item. You must document your justification. You must have something to show for the 4 bullets in 61511. Now, I'll point back to you. I'll point back to that slide and think about it for a minute. If you have a reputable manufacturer, you should be able to get them to send you their quality certificates. And if you wish to accept that, fine, you've met bullet number 1. Because it's up to you. There's not a lot of detail in 61511. It's your responsibility. You're responsible for the plant safety, and you must do what it takes to meet 61511 and justify your own conscience for how to make sure things are safe. But I would say you never can do it. Well, I'll be specific. If exida were hired to audit your design process, you would fail if you only used catalog equipment as the means to justify equipment. You need to do something to satisfy all of the 4 bullet points. Now, on this slide, we are talking about the things that exida does, as an example. What about the next bullet point? Adequate identification and specification. For SIL 1, we verify that the manufacturer version control, we verify that the manufacturer has version control of all mechanical hardware, electronic hardware, and software. And the versions need to be documented and clearly marked either on the product or accessible via handheld. Now, you mentioned Emerson in your question previously, and I can verify that for the instruments exida has reviewed, the versions are available via the handheld. But you need to check that. I'm not certain that all products by every manufacturer meet this criteria. For SIL 2, we do all this, plus we review the version history. And for SIL 3, we also audit manufacturers' version history and field failure feedback. Demonstration of performance. This is so controversial. How do you know it works if you haven't used it? How do you know it works in your application if you haven't used it? Well, you have to monitor field performance. You know what it said in the standard: similar operating profile and environmental performance. So this makes perfect sense to me. If you use a bunch of this equipment for control purposes, other than mechanical stuff, you'll be able to justify it for safety. It's the same operating profile. Now, how much do you have to monitor it? Well, you have to set up you really should have a good field performance monitoring system anyway, because there's a lot of cost savings involved in recognizing problems before they shut down your plant. And many of you from the plant thoroughly understand the cost of a shutdown. So field monitoring systems, in my opinion, should very much pay for themselves. Now, once you've got one, you can use it to help justify your equipment. Now, you have to remember it's more than just a false trip. It's most important that you recognize dangerous failures, and you normally find them by proof testing. Well, you find them by monitoring the automatic diagnostic output, keeping track of the error codes, and by proof testing. In other words, keep track of your proof test results. And 61511 already says you have to keep records of your proof tests. So there's nothing special here. If you do all of that, and again, all you have to do is meet the requirements of the standard if you wish to proclaim you're even meeting the standard. If you don't wish to meet the 61511 standard, you can do whatever you want. It's your plant. Most people are buying certified equipment because they don't want to take the responsibility, and there's a lot of it out there today. Barrier number 2, calculating probability of failure on dangerous failure. There's 2 modes, low demand and higher continuous. You must calculate a PFD average or a PFH. Today, this sort of thing is so easy. I had another question. Let me stop. If field devices are manufactured and certified in one country, does the same certificate valid if the field device is manufactured in another country? The answer is yes. For the most part, the functional safety certification is based on the design. So the answer would be yes, unless they have changed the design. So 2 things have to be met. Number 1, they can't change the design. They can't change the hardware. They can't even select alternative components. But number 2, they also have to have a quality system that matches 61508. I will tell you that in exida, we are asked we ask, where is the product manufactured? And in many cases, there are 3 or 4 different manufacturing locations in many different countries. and we will check the manufacturing quality of every single location. Thanks for asking. Today, in terms of back to barrier number 2, most people use commercial tools. I use the Excellentia software. Excellentia will account for all the variables in a PFD or PFH calculation. You input the demand mode or the demand rate, and it will automatically calculate the appropriate low demand number or the high demand number, and it will give you the PFD calculations and the architecture constraint numbers for any given SIF design. So a lot of people think barrier number 2 is all that is required, but in fact it's one of 3. But most people understand how to do the calculations. You can certainly do them by hand if you have lots of time available. And there are, I can think of at least 6 different commercial tools on the market today. So that barrier is pretty well understood. The SIL capability is something that has been in 61511 since it was introduced in 2003, but a lot of people are just learning what it means. The last barrier, and one of the most controversial, architectural constraints. You must check for minimum levels of redundancy based on one of several different charts. Now, it is several different charts. First of all, you can use the 61511 charts. They are simplified versions of the 61508 charts. You can go to the 61508 charts, and you can either use the old charts based on route, what's now called Route 1H, or you can use the newer chart, which is based on Route 2H, which depends on high levels of data quality. It's much like the prior use identification. Now, 1, 2, 3, 4, 5, 6. I'm thinking there are 6 different charts. Oh my goodness, which one do I use? You get to choose. In 61511, there's 2 charts, one for logic solver, which really matches the content is identical to the 61508 type B table, but 61508 is a little more, is more flexible and therefore more complicated. So this is a simplified version of that. Number 2, 61511 has a chart for field equipment. It's very simple. SIL 1, you can use a single device. SIL 2, you got to have 2 of them. For SIL 3, you got to have 3 of them. And we don't mean 2 out of 3. We mean 1 out of 3. And quite frankly, I've never seen a design like that because the false trip rate goes it triples. You don't want the false trip rate to go up. So I don't see people using this chart, quite frankly. Often, when prior use justification is done, they will use a note in 61511 that says they can decrement the architectural constraints by 1 level if you have good field failure data. So for SIL 2, I can use a single transmitter. For SIL 3, I need hardware fault tolerance equals 1, which means a 1 out of 2 or a 2 out of 3 architecture. Question. Virgo valve is achieving only 20% safe failure fraction in tight shutoff mode. Systematic integrity is SIL 2. Can proven in use justification be used to increase the level up to SIL 3? And the answer is yes. You can use, I would use, if I were attempting this, I could do a full audit of this valve manufacturer, And you are absolutely allowed to do your own prior use justification. You can certainly use the certification results as partial evidence, but you have to have additional evidence, for the most part, based on your experience. I guess I thought that particular product had a systematic integrity of SIL 3. I do think you might want to go look at that certificate again. I can check it later. Send me an email after the web seminar. I'll check it for you. You can certainly check it on the safety automation equipment list. But you're absolutely allowed to use prior use justification to raise a SIL 2 to a SIL 3. Now, we're back on barrier number 3. Oh, another one. I thought systematic SIL was the highest SIL that can be achieved. The words you're using are not correct. Systematic capability is the highest SIL level in which a product may be used unless justification is done for a higher SIL level. The certification cannot be used alone as the justification. Hope that simple one explains it. So we have 3 different charts now for 61511. The logic solver chart, which is a simplified version of 08. The field failure chart, which is pretty restrictive and well, not used because it's so restrictive. And the prior use field equipment chart, which is commonly used because people don't believe they need more than 2 out of 3 transmitters for SIL 3. And of course, I'll show you some evidence that that's probably true. 61508 has 2 charts, one for a type A device, which is considered a simple device with well-known failure rates. And this is per IEC, the new 61508 Route 1H, it's called, where you calculate a metric called safe failure fraction. And for an element, and there's a great debate as to what is an element, at exida, we have had long debates, even with other certification agencies, and we've all concluded that, for the most part, that it's not an individual instrument, but a collection of instruments that perform a safety function. But we could do a whole web seminar on element. Right now, I just want to show you architectural constraints, a chart for type A and a chart for type B that's basically 1 SIL level higher. Now, type B is a complicated device. Certainly anything with software or complicated state machines. And the concept is these devices are so complicated, we don't know all the failure modes, and therefore we have to be more conservative. Conceptually, I do agree with that. Until you get good failure rate data. So far now, we have 3 charts from 61511 and 2 charts from 61508. Well, which one do you use? Answer? Depends whether you have a type A or a type B product. Depends on whether it's a field instrument or a logic solver. But you can pick whichever chart is appropriate for your problem. Now, these 61508 charts, in fact, the whole concept of architecture constraint definitely had problems. There were artificial redundancy requirements when short proof test intervals actually existed, and I give you an example of a batch process which was tested every day. It's absolutely possible to have a very, very safe product and not meet architecture constraints under this circumstance. And there are some very artificial redundancy requirements when simple devices were combined with type B devices. For example, in the 2000 version of 61508, it was commonly interpreted that if I add a remote seal to a pressure transmitter, the failure rates needed to be added. Then the safe failure fraction was calculated. And in that case, it means you had to add another set of equipment, but in fact, the PFD average showed that you were more than safe enough. And the committee recognized that these were serious problems and made changes in the 2010 version of 61508. What they did was created Route 2H, where they reduced the architectural constraint based on having a high confidence in the quality of failure data. They said we want 90% confidence, but many, including myself, interpret this to mean more than simply using a statistical uncertainty of 90%. It means really having good, strong confidence in the entire data collection process. And, of course, understanding that applications and environments must be similar. You can read in 61508, the details are you have to have an amount of field feedback, you have to have expert judgment, and sometimes you have to have specific tests. That could be a cycle test if you're in a high demand environment, or it could be fault injection testing to verify the effectiveness of an FMEDA. But what's not in 61508? There's still no limit on the number of hours required, no specific requirements for time in service. And anybody that's been on a committee knows that means the committee could not agree. Anyway, if you believe a product meets 61508 Route 2H, you do not calculate a safe failure fraction. Instead, you use a table which exida has constructed from the words in the standard. And ironically or appropriately, it's identical to the 61511 2003 proven in use chart, which you can see if you compare them. Now, as a certification body, exida may also use must also check architecture constraints or provide the information to check architecture constraints for each element. For any product that might be an element, we do check this, and we either use Route 1H or Route 2H criteria. But as a certification body, we must document the exida scheme, it's called, and that means detailed interpretations of standards. And so for exida, we publish our Route 2H criteria, which we believe more than meets IEC61508. We were hoping on creating criteria that couldn't even be argued with. So we have 100 million unit operating hours required. We need documented, traceable field failure studies. We have to have field operation of 1 year or longer. And you can imagine why that is. I mean, sometimes it takes, on average, 6 months for these things to be installed after shipment. And there has to be an FMEDA done per components that meet the 2H criteria. This is not in 61508. This is just our interpretation because 61508 did not have sufficient details. So we create, like all certification bodies, like all responsible certification bodies, we write down and publish all of our specific criteria. Now, the business about the FMEDA is important because in order for any FMEDA or any, quote, laboratory exercise to be valid, it has to be based on real data. At exida, our component database is based on field failure data, and that is used in an FMEDA analysis. And this is exactly what we believe Route 2H is telling us we must do. Fortunately, we've been doing this now for 12 years. We have over 60 billion unit operating hours of field failure data from end users, primarily in process industries, offshore, chemical, refining. Nuclear, we do have nuclear data and power industry, conventional power data. We do see the differences in the environmental profiles, and we've recorded all that. And to me, that data is essential for meeting Route 2H. Now, just to double check, we did a study of over 50,000 SIF designs in our database. And ironically, architecture constraints gave us the same SIL level as the PFD calculations 70% of the time. 15% of the time, the PFD was the limiting factor on the SIL. But, and here's the important part. What about 15% where the architecture constraints limited the SIL? Doesn't that mean that these architecture constraints are very, very important? The answer is yes. However, digging in, we discovered that 10% of the time, the architecture constraint limited the SIL based on short proof test intervals that were valid, like this batch process. In the other case, 5% of the time, and analysts were not using the exida FMEDA data, and they entered their own failure data that was extremely low. And that's kind of dangerous, actually. But, in fact, when using Excellentia FMEDA failure rates, the PFD calculations limited the SIL level, legitimately the SIL level in every case except short proof test intervals, where in fact architecture constraints were not applicable. So in general, the Route 2H is something that is very, very valid. And it also allows me to completely support the 61511 prior use architecture tables. Question, what would be an example of a short proof test interval? 24 hours is a good example. I've seen many safety instrumented functions where they are operated for a batch, like 8-hour run, and then they shut down and reload for a new batch. At the beginning of each batch, an automated test is done, including, in many cases, leak testing of the valves. Some of the stuff is very well designed. Of course, it's really important those valves don't leak, or you'll have a big explosion. So, short proof tests don't require architecture constraints to give us safety, especially when the testing is done so frequently. Thanks for asking. Based on this evidence, a lot of people felt Route 2H was, quote, dangerous and should not be used. But based on this study and based on the fact that the 61511 chart has been the same since 2003, I felt very comfortable with the Route 2H process. And to verify this, we have a lot of comparisons have been made of field failure data and FMEDA data. You can see at the top of this chart there are some failure rates for based on customer studies or manufacturers' studies. The Dow study had 4.96 e to the minus 7, and that matches up very nicely, you'll see, with the FMEDA results for a number of different pressure transmitters. The IRETA data, which is generally a bit high, they publish a 3 times 10 to the minus 7, and the FMEDAs are coming in that range, although sometimes the FMEDA numbers are a lot lower. But IRETA doesn't tell us whether that includes a remote seal or a manifold or an impulse line. I suspect it's an average of all of those, And in fact, when I throw in failure rates for remote seals, we're starting to get very close. And when I throw in failure rates for impulse lines and manifolds, FMEDA numbers match up with ORETA numbers pretty closely. So the architecture comparison done by the FMEDA seems to be a pretty, the 2H approach seems to be pretty good. Now what do we end up with? 1, 2, 3, 4, 5, 6 different charts. The 2H approach, by the way, it doesn't say field equipment or logic solver, but for the most part, architecture constraints can be a bit confusing. So barrier number 3 is a little tougher than most, but you have a lot of flexibility now in solving the problem. The exida route 2H approach, of course, requires the FMEDA data for all the components in a product. Then the product is declared 2H compliant, and then you can use the 2H chart. So, you're probably glazing over by now. This is a lot to absorb, and we do have a separate seminar in each of these subjects. 2 of them are currently recorded if you want to go look at them right now. We do have a complete web seminar on systematic capability and another one on architecture constraints and another one which is coming on barrier number 2. I thank you for your attention. Anybody else? Oh, there's a valve manufacturer. Tight shutoff mode. Tight shutoff mode has a lot higher failure rate, but that's not systematic capability. Systematic is still 3 capable. That's what I thought. The valves are proven in use. Manufacturers may be using terms that are very common. I have no idea. As per standards, as per the standards, what's the least SIL integrity? Okay. There are 3 barriers, and you can see them right now on your screen. If I have a valve with a systematic capability of 3, and I calculate a PFD average, which gives me SIL 1, and I find architecture constraints limit me to SIL 1, lowest number wins. Just because I have SIL 3 capability does not mean that valve can be used, one valve can be used in a SIL 3 design. It's highly likely that the PFD numbers would force you to put in at least 2 valves, and the architecture constraints would probably also require you to put in 2 valves. Okay, while generating the reports is not reflecting why. While generating the reports relay data. In all my experience with the exida Excellentia tool, all the failure rate data for all the components does appear. If you're not seeing that, I'd put in a request for some help. Can you tell me in which chapter 61511 is the systematic capability? I'll have to look that one up. The chart that I showed you in this presentation, I do happen to have a copy right here. That chart I was talking about is Figure 3, Part 1. I was hoping it would refer, it says Clause 1. And so the figure that I showed you from 61511 is Part 1, Figure 3. You'll have to look for the details beyond that. All right. We actually got done in an hour because I got a bit of a late start getting everybody up and running. So I thank you so much. If you have any questions or any further comments, do not hesitate to send us an email, and we'll get back to you asynchronously. Sometimes it takes a while to get these things answered. And I thank you all very much for your attention. Don't forget about the safety automation equipment list, and stay tuned for more web seminars. Enjoy the rest. Oh, one more question came in. Let's go ahead and answer. Thanks. Okay, somebody was late. Thanks for the session. I appreciate your comments, folks. Stay tuned for exida web seminars if you feel they are of value. Our intent is to help people understand functional safety and make the world a safer place. Thank you all for attending. See you next time. Goodbye.